A higher order derivative just means we're taking a derivative multiple times. So for example, if our original function is f of x, that's our function, then the first derivative is f prime of x. The second derivative would be the derivative of f prime of x, so that would be f prime of f prime of x, which would be f double prime of x. And then the third derivative, we'd take the derivative of the second derivative. So the third derivative would be f triple prime of x. And we could keep going. The fourth derivative, now we're kind of getting up there in the tally marks. So when we get to a large enough number, we usually write derivatives like this. F4 as like a superscript in parentheses would mean the fourth derivative. Okay. So that's one way that we're going to see these written, but we have our other notation, such as if our function is written as y equals, so y is our function. Then the first derivative we write dy dx. The second derivative we're going to write d squared y over dx squared. That shows we're taking the second derivative. Okay, let's do an example with a polynomial function. We're going to find as many derivatives as we can of the function f of x equals x to the fourth minus x to the third plus 5x squared minus 12x plus 2. Okay, let's start by finding the first derivative. Using the power rule with each term, we'll get 4x to the third minus 3x squared plus, bring down the 2 times 5 is 10x to the first minus 12. Derivative of the 2, which is a constant, is 0, so we don't need to write that. There's our first derivative function. Now the second derivative will be f double prime of x. And that means we take the derivative of f prime of x. So that will be using the blue function to get the red function. So power rule, bring down the 3, multiply to the 4 is 12x squared minus 3 times bring down the 2 is 6, x to the first plus 10, and derivative of negative 12, which is a constant, is 0. And we can keep going in this way. So the third derivative we're going to find using the second derivative. Bring down the 2, 24x minus 6, derivative of 10 is 0. And now the fourth derivative, we use the third derivative, and now I'm going to change my notation for parentheses 4 to show fourth derivative. Derivative of 24x is 24. Derivative of negative 6 is 0. So there's our fourth derivative. And then the fifth derivative, f written in 5 in parentheses of x, is going to be 0. And so will every derivative past the fifth derivative. So the sixth derivative would be 0, the seventh derivative, eighth derivative, and so on. So to find a higher order derivative, we just need the derivative before, and we take the derivative of that function before.